All right, welcome to this video. I'm actually in Russia now. I wanted to record this earlier, but was tired and busy and tired and, well, busy. So I'm recording it now and I will upload it to YouTube once I'm done. So I wanted to talk a little bit about hashes, a little bit more about hashes. So if you remember, when you have a password and you want to store it somewhere, you take that password and you don't store it directly in a database or directly in a file or something because that's bad. Anybody who has access to that database can actually access the password. So instead, what you do is you run it through a hash. And the hash basically takes that password and it's a one-way direction and generates a unique string for it. And the key to it is that's not reversible. If you have that string, that hash, you cannot get back to the password. So one of the popular ones back in the day, and this was, so this was released back in 1991, is called MD5. And so on Linux and on Mac, you can just type MD5 sum. On Windows, there's a way to do it, but the command's a lot longer. And you can just take anything. You can take MD5 sum and type in a string. And then if you hit Control D, then that will end its input. You have to do Enter and Control D. Okay, so notice that that is the hash for just typing hello. If I make any change to this, I'm going to do this all in lowercase. Notice it is a completely different hash. And I went over this in class, so this should be familiar. But the key thing is the hash that it produces is unique. There should never be two hashes which are the same for different content. And so if I go here and I look at these two images, MD5 Star Wars. Star Wars at JPEG, and then, I renamed that and I forgot to rename it back, but that was JPEG out also. MD5 Star Wars embedded, and this was when I demonstrated the stenography. The reason why this is changed is I wanted to demonstrate that this sum doesn't change if the file name changes. Embedded.pg. So now I just renamed it back, and if I do a MD5 sum on that, notice that these are exactly the same, even though the file names were different. So just changing the file name is not going to change the MD5 sum or the MD5 hash. It has to actually have content which changes. And so this was released, MD5 was released back in 1991 by a guy by the name of Ron Rivest. And when he released it, it was starting to get used everywhere. People saw that it was unique for every different value and everything. But then researchers started to look at it and they started to wonder, is there a way that two different things can have the same hash? And so this leads us into what's known as the birthday problem or birthday paradox. And those of you who may not know that, it's a topic in statistics or number theory where if you take a group of people and you ask people what day their birthday is, once you get to 23 people, then statistically you have a 50% chance of at least two people having to share the same birthday. Once you get a little bit higher than that, then the percentage jumps up to 99%, and it's not even that much higher than 23. Maybe it's double that, but still, if you have a room of 50 people, you have almost 100% chance of two people sharing the exact same birthday. And hashes or hash collisions work off the same principle. You have a number of possibilities, and that's the size in bits of the hashing algorithm. And if it is small enough, then you have a possibility of a collision between two different types of data. And so I'm going to run these programs first, and then we will go ahead and see that they do something different, and we'll see what the MD5 sum is. So first off, unfortunately, I had to download the Windows version of these files, but it's not going to really break anything. So if I go here, I go there, there's two files. They're the same size, but one is named hello and one is named erase. So let me go ahead and run hello. And it says hello world, press enter to quit. Okay, now let me run erase. This program is evil, erasing hard drive, just kidding, nothing was erased, press enter to quit. Notice that each program produces completely different output. Hello world versus this program is evil, erasing hard drive, so on and so forth. Now let's look at the actual MD5 sum. So I copy them, let's see, there, and MD5, gosh, there we go. All right, so those are the two files. Notice it's at the same location, so I'm not, you don't think I'm doing anything sneaky. If I do MD5 sum of hello, notice I get this MD5 sum, CD C47D, so on and so forth. Now if I do the MD5 sum of erase, this should have a different MD5 sum because they are different programs, they have different output. But notice that the hashes are exactly the same. This is a hash collision. These are two separate programs that do two different things, but they have the same MD5 sum. And that is a problem because, sure, these programs just printed out to the screen, but if you can imagine, there are attacks where when you download a file from the internet, and let's see, I remember seeing it, let's see, Conda. And I think I saw it here. Actually, let me do a search for Miniconda. Miniconda and hash information. Okay, that didn't actually do it. Okay, so these have SHA-256 hashes. They don't actually have MD5 hashes, but a lot of sites, when you download something, they will give you an MD5 sum or an MD5 hash number. So when you download it, you can run it through MD5 sum or whatever the hash algorithm that they generate it with to verify that what you downloaded is exactly the same as what you expected to download. And so usually this is secured to where nobody can change it, provided that those files aren't changed. And that kind of that's designed to prevent like man-in-the-middle attacks where somebody can intercept your traffic and then replace a file with their own malicious file. But if you can somehow generate a file with the exact same hash as another file, that's a problem. Or if you have a document, let's say you have somebody who creates two documents, a document that is it says, I will give you $1 million, like a contract. And then they also generate a document which says, you will give me $1 million. And you sign the one which says, I will give you $1 million. And they look at the document and they can find specific points that they can change. Then they can perform an attack, a clash against that document's MD5 sum to generate a document, an evil document with the exact same sums. And so then, even though you may have a document which says one thing, they have a document which says another, the hashes match. And so who do you actually believe at that point? So with passwords, it's the same thing. If you can somehow figure out what a hash is for a password, you can generate text or strings of text, or you can generate images, you can generate all sorts of stuff which may have that exact same hash. And so there's a site here. This was published back in 2006. And this is actually about the MD5 collision. And this is where I got the hello and erase files from. But this is where he demonstrates that this is exactly the same up until this bit there, which is an 8 there, and it's a 0 there, and it's an F here, and it's a 7 there, and so on and so forth. And so he demonstrates that these two strings actually produce the same hash, even though they are different. They each produce this MD5 hash. And so you can read through this, and he goes into a lot of detail about it. There's also this site here where you can create your own MD5 collision. And basically what you do is he has a AWS instance. You upload an image and you upload two images and you generate a collision between the two. It may take a while to find the collision between these two images. He says that this took, he started at 10 in the previous morning and it took until 2:45 in the morning. So quite a lot of time, 16 hours. But he's demonstrating that with two different images, they can get the same hash. And so he used this project Hash Clash, which is an open source project. Notice that it's a framework for MD5 and SHA-1. SHA-1 is also another hash which has been deemed unsafe because it is also susceptible to these collision attacks. So older systems are nowadays the only ones which are using these older hashing algorithms. However, there's a lot of old systems out there. So I just want to give you a very quick rundown of hash collisions. So go ahead and read more in the book, read these websites, and I hope you enjoyed it. Thank you.